Okay, we have come to the last part of the fifth unit. In this session, we'll be discussing about the linear regression, which you have already studied in the subject machine learning. Here, what we can do with R to implement this, that we'll focus on that technique rather than what is linear regression, but I'll just brush the fundamentals of the linear regression. So linear regression is a very, very widely used statistical model for exploring the relation between variables, independent variable y and dependent variable x. So what it does, it models how the linearly y will vary with x. This method is also called ordinary least squares method because we'll be adjusting the quotients based on the squared error. So for example, you have independent variable y and dependent variable x. So what is the straight line equation? Y is equal to mx plus c. So this is m, then this is c. That is the simplest linear regression. That means we are assuming that y is varying with x linearly with these quotients. And this is the error, random error term. So slightly for the complex model, I can write yi is equal to beta naught, which is a constant, beta 1 x plus epsilon error. So in linear regression or linear model, our attempt is to estimate beta naught and beta 1. This is what we are going to do. So once we assume beta naught, beta 1, we want the actual value y and the estimated value, the difference between these two square, we want that to be minimum. That's why it is called ordinary least square. We want the difference to be very much minimum. So I already told you this is intercept, this is slope, y is equal to mx plus c is the linear model. So we'll be assuming that there is a linearity, but you know that most of the times the data is not linear. That's why where we included activation function in our model. So in R, we have a simple command called lm, which will fit the data. Fit is a variable that I am choosing. LM is the linear regression model. So let us do this with a simple example. So I have a data here with the data frame. So I can print the summary of this, or let us say structure better than summary, because we are not using box plot, we are using. So this is the structure of the data. So, and I want my linear model fit is equal to LM linear model, and that I want as data. And I can plot the summary of that fit. Sorry. So this is the summary. So minimum, this is 5 number, lower quarter, higher quarter, third quarter, first quarter, median, max. This is the 5 number summary, and these are the intercept. So this is the value of C, and this is the value of me, slope. So this is how we can fit a linear model. So what we have done is simple linear regression. That means we are assuming only one quotient, and you can have multiple linear regression. Let me plot it. You can also plot the graph whether. So plot fit. It will give the, so this is the, let me zoom it. So this is the plot of residual, this is the linear model data, and this is the error. How much is the error? Then we can also have multiple linear regression where we'll be depending on more x values, x1, x2, x3. This is known as multiple linear regression. Instead of one independent variable, there may be two, three independent variables. For example, uh, a student getting job, maybe depending on his percentage, his communication skill, that is x2, then his IQ, that is x3, and his coding skills, x4, so on and so forth. So you can fit that and you can print summary. So this is about linear regression and multiple linear regression and simple linear regression.